Imagine gazing at the horizon and witnessing a sunrise that spans half the sky. NASA has released images of an unprecedented phenomenon where a star named Betelgeuse blew its top off, ejecting a massive portion of its surface mass. This event is called a surface mass ejection, and according to the Space Agency, the ejection was 400 billion times the mass of an ordinary solar flare from our Sun. Scientists describe this as witnessing stellar evolution in real time, with the star blasting off such huge chunks of its physical form, surprising many. The catastrophic explosion of the super-red giant is challenging much of what we know about the universe. Why did Betelgeuse blow its top, and how will that affect the universe? Let's explore. Constellations are composed of many stars and are arranged according to mythology and legends, still used for navigation today. One such star is Betelgeuse, one of the largest and brightest in our night sky. This brilliant ruby-red star, located in the upper right shoulder of the winter constellation Orion the Hunter, is recognized by astronomers as a seething monster with a 400-day-long cycle of regular pulsations. Its dull orange-red color makes Betelgeuse easily identifiable and ideal for convincing skeptics that stars do have different colors. Known also as Alpha Orionis, it is the second brightest star in the constellation, after the blue supergiant Rigel. Betelgeuse is intriguing for study due to its variable nature and unusual name. Stars with the name Alpha are typically the brightest in their constellations, yet despite Rigel being brighter, Betelgeuse holds the Alpha title due to its size, brightness, and reddish hue. It's also well known as the model for both the character and movie Beetlejuice. Betelgeuse is the 7th brightest star visible to most of North America, Europe, and Canada, and the 10th brightest overall in the sky. Earth is relatively close to Betelgeuse, though astronomers can't pinpoint its exact distance from Earth, estimating it between 430 and 724 light-years away. Betelgeuse is the brightest red supergiant star closest to Earth in our galaxy, with just 200 such stars identified. Its radius is about 764 times larger than the Sun's. If Betelgeuse were to replace our Sun, it would extend past the asteroid belt and beyond Jupiter, suggesting that Earth, Mars, Venus, and Mercury would all be completely absorbed. Betelgeuse is 16 to 1,128 times as massive as the Sun, with 126,000 solar luminosities visible from 548 light-years away. Its surface temperature is about 3,600 Kelvin, making it cooler than the Sun. Only about 13.3% of Betelgeuse's radiant energy is visible light. If human eyes could perceive all wavelengths, Betelgeuse would outshine Sirius as the brightest star in our night sky. Betelgeuse loses about 1 solar mass every 10,000 years, surrounded by a nebula formed by unevenly ejected material, 250 times larger than the star itself. The size of this nebula is thought to be 30 astronomical units, the distance between the Sun and Neptune. Our solar system's Sun regularly ejects mass into space through solar flares, releasing tiny fragments of its outer atmosphere known as the corona, resulting in coronal mass ejections, CMEs. CMEs and surface mass ejections can occur separately, and when a star ejects part of its unstable outer atmosphere, it causes a CME, known as the corona CME. Solar system CMEs occur frequently and can impact Earth and its inhabitants. CMEs can travel over 1,800 meters per second, ejecting magnetic fields and plasma into space, sometimes reaching Earth in hours. When a CME occurs on the Sun's side facing Earth, it can disrupt and damage satellites and power infrastructure, occasionally endangering astronauts in orbit. The recent discovery shed light on Betelgeuse's dimming in 2019, when ejected material exploded into space, cooled, and formed a cosmic dust cloud that obscured Betelgeuse's brightness from Earth-based observers. Betelgeuse's known steady pulsating pattern has changed. Betelgeuse's CME is unusual because it released 400 billion times more mass than a typical CME, causing the star to shake like a dish of gelatin desserts, according to a NASA news release. Andrea Dupree, an astronomer at the Center for Astrophysics, suggests that the star's internal convection cells may be disrupted while the photosphere struggles to reconstruct itself. Astronomers have been monitoring the star's constant pattern for 200 years, but it no longer exists. All red giants, including Betelgeuse, are dying, and observing this process can teach researchers about star evolution. Most stars in the cosmos are powered by nuclear fusion, which eventually burns out, leading to intriguing stellar changes before a star finally perishes. When a star is born, it is composed of hydrogen, which, under gravity's force, fuses in the star's core to create helium in a nuclear explosion, releasing heat and light energy. This energy travels to the star's surface and is emitted as photons into space. As a star ages, its primary fuel, hydrogen, depletes, and helium begins to combine with carbon to form carbon. After helium is exhausted, neon will eventually combine with carbon to form iron. When iron fusion begins, it absorbs energy instead of releasing it, leaving nothing to oppose the star's strong gravity, causing it to collapse and triggering a supernova explosion. A supernova, one of nature's most powerful forces, can generate more energy than 10 billion suns. Stars change hue over their existence from young, hot blue forms to older, cooler red varieties, depending on their stage of stellar evolution. The Greek scientist Ptolemy in 168 AD referred to Betelgeuse's color as ruddy, while Chinese astronomers 3 centuries earlier described it as yellow, possibly indicating Betelgeuse was once a yellow supergiant. Larger stars burn through their hydrogen faster and die off sooner. Despite being only about 10 million years old, Betelgeuse is nearing the end of its lifespan. Our Sun, however, is still in its prime at approximately 5 billion years old. Given Betelgeuse is nearing the end of its life, a supernova could happen soon. Betelgeuse undergoes 2 dimming and brightening cycles, the second occurring every 5 years and lasting about 100 days. The star's outer shell is thought to expand and contract during this cycle, altering its circumference and average temperature. Betelgeuse's explosion might help astronomers understand how red stars lose mass in their final days before exploding in a bright supernova. As Dupree notes, we've never seen such a large mass ejection on a star's surface before. We're left with something we don't fully understand, a new phenomenon observable directly, with surface details resolvable using Hubble. We're watching stellar evolution in real time, though it's unclear if this signifies Betelgeuse's impending supernova explosion. Because the findings are so unusual, NASA warns that Betelgeuse may not have reached the end of its life, even if nearing its end. Cosmic time is long, and red supergiants die quickly by comparison. NASA estimates Betelgeuse will explode in the next 100,000 years. Betelgeuse has been studied intensely since the 1st century BC. More recently, a scientist named Sarafina Nance and her team sought to determine when supernova explosions of red supergiants like Betelgeuse might occur. They ran multiple simulations using Betelgeuse as a model to understand its behavior over time, then compared findings with field observations. Why did Betelgeuse suddenly diminish out of sync with its regular cycle when it's unlikely to explode for another 100,000 years? Betelgeuse was ejected from its home in the Orion OB1 association, containing Orion's belt stars, and has moved through the interstellar medium at a speed over 4 light-years wide. By mid-February 2020, Betelgeuse lost about 3 times its brightness, from magnitude 0.5 to magnitude 1.7, after a sharp decline starting in October 2019. By February 17, 2020, Betelgeuse's brightness stabilized for almost 10 days, then began to brighten again. However, Betelgeuse seemed to have stopped dimming completely 5 days later, effectively ending the dimming episode. Given no significant infrared changes on February 24, 2020, the recent visual fading seemed unrelated to anticipated core collapse. Another study concluded that the star's dimming likely resulted from a cloud of large-grained circumstellar dust. Dust absorption was ruled out from having a significant effect in a study using submillimeter wavelength measurements, but fading seems caused by large star spots. Further analysis showed a dramatic rise in Betelgeuse's brightness between May and August. Betelgeuse is so close to the Sun that it's almost impossible to see from Earth before 2020, when Betelgeuse was in conjunction with the Sun. Its brilliance was observed to shift widely, making predictions difficult. The fading suggests a second dimming event may occur sooner than expected. The discovery of a second dust cloud linked to Betelgeuse in June 2020 suggested that a cool patch on its photosphere might cause the dust. In August, a second independent investigation confirmed the hypothesis. The dust is believed to have formed from gas ejected by the star. According to 2022 Hubble Space Telescope studies, a clouding dust might have formed due to a surface mass ejection. Material ejected from the star's surface traveled millions of kilometers away, where it cooled, compacted, and formed dust, covering the star from earthly observers. The fading began in late 2019 and continued through early 2020. In 2022, the Hubble telescope witnessed another surface mass ejection 400 times more significant than any coronal mass ejection observed on the Sun. Scientists hypothesized that the gas was ejected 2 years earlier from a massive convection cell that covered a sizable portion of the star's surface. In July 2023, 3 studies based on James Webb Space Telescope data suggested that a dust cloud produced by a surface mass ejection was responsible for Betelgeuse's significant dimming. Scientists are attempting to learn more about how massive stars like Betelgeuse eject material through these extraordinary instances. While Betelgeuse's explosion won't threaten life on Earth or its inhabitants, it will likely leave a visible display in the night sky for weeks or months. It's unknown what impact such a supernova will have on neighboring stars and planets. Betelgeuse is far enough away that its collapse and explosion should have little impact on Earth. Observers worldwide would likely experience an extraordinary sight for weeks or months, perhaps even visible in daylight. A beautiful nebula visible from the southern hemisphere would then take the star's place. Scientists would learn much about stellar and supernova evolution. If Betelgeuse eventually explodes, it might appear as a beautiful bright dot in our night sky, akin to a full moon. Its explosion might alter our night sky so that it no longer includes Orion's distinctive belt pattern, resembling Orion without a shoulder. The brilliant nebula left in its wake would outshine the brightest stars for months, potentially illuminating the night sky with greater intensity than the moon for weeks. Ultimately, a large explosion might cause Betelgeuse to be consumed into itself, leading to the formation of a neutron star, with its remaining mass collapsing into a black hole. Astronomers have much to learn from Betelgeuse's explosion. But for now, it's unclear what lies ahead. Betelgeuse's extreme mass ejection may signify an imminent collapse. The cause remains unknown, but Betelgeuse's outburst offers scientists unprecedented insights. NASA continues to monitor Betelgeuse, exploring it through instruments like the James Webb Space Telescope, the Hubble Space Telescope, and the Spitzer Space Telescope. NASA notes that Betelgeuse's mass ejection offers a unique opportunity to learn more about stars' atmospheres and red supergiants as a group. The stunning event is something we've never witnessed before, and researchers are eager to learn more. Overall, Betelgeuse's explosion highlights how much we still have to learn about stars and their processes. Observing these extraordinary events may help us learn more about the early stages of star formation and the mechanisms that lead to mass ejections. Stars serve as the universe's engines, and much remains to be discovered about their lives and deaths. Betelgeuse's explosion provides a once-in-a-lifetime opportunity for scientists to study the cosmos.